Hello everyone, we're going to simplify some rational expressions, and we've been talking about it all year. It's not going away. If you're going to simplify a rational expression, you need to factor. So there's a lot of factoring, and I'll tell you that these problems today are relatively easy factoring. We're just trying to get the concept down. The factoring I expect of you is more difficult than this. One thing that we're trying to get you to realize is that this fraction bar, this guy right here, this line down the middle, that's a division operation, okay? So the reason that we're factoring is because division undoes multiplication, and factoring turns these binomials into products. So for this first problem, what I'm going to do, I can't factor 9x cubed, so I'll leave that alone. But in the denominator, I will factor everything I can, the GCF. So the GCF between x to the fourth and 4x cubed is x cubed, and now I have x plus 4. So what I was getting at is, this is multiplication. And this division undoes multiplication. So if you have x cubed over x cubed, anything divided by itself is 1. So that cancels out, and now you have 9 over x plus 4. And you are done. You cannot do anything else. Okay? And I'll keep coming back to this idea, but this quantity, those are connected by an addition sign, so it's all or nothing. If x plus 4 doesn't go away, nothing goes away. But since we factored here, that multiplication can be undone by division. Same idea here. The GCF in the top is x. In the bottom you have 2x squared. Now, you have x divided by x times x. One of those will cancel out. Now you have x plus 7 over just 2x to the first. And again, that is all you can do for those problems. Now, a little bit fancier factoring, but pretty much the same. This is a trinomial, but since it's 1x squared, I can do this pretty quick. The numbers that multiply to 63 and add to 16 are 9 and 7. So x plus 7 and x plus 9. And then this is a difference of squares. X plus 9, x minus 9. Now, we are looking for factors that are identical, that I can cancel out. Got one. I don't know what x plus 9 is, but I know if I divide it by itself, I will get 1. So this becomes 1, and now you have x plus 7 over x minus 9. You are finished. You cannot cancel anything else out because, again, x plus 7 is connected by an addition. This division does not undo it. You can't cross those out because these are not the same. These are connected to each other. This is one quantity. Unless the whole thing goes away, none of it goes away. Let's try another one. In the top, I have a GCF of 2x, and that'd be x minus 6. And in the denominator, the numbers that multiply to negative 18 and add to negative 3 are negative 6 and positive 3. So since you have this entire thing canceling out, that's fine. Now you have 2x over x plus 3, and those are connected. You are done. Okay, unless the whole thing goes away or you factor something out, you can't cancel anything else out. So multiplication is just pretty much a bigger problem. We're going to do the same thing twice. I pretty much pretend like this is one big fraction bar because it is. But now I'm going to factor everything I can. X squared, okay, well, I can't factor that. X squared minus 4 is x plus 2, x minus 2. So these are all being multiplied in the top. In the denominator, down here, GCF is 4. And the numbers that multiply to negative 16 and add to positive 6, they have to be opposites. X plus 8, x minus 2. So now, these factors are all fair game if the whole thing goes away. So does anything go away? Yeah. Anything else? Yeah, right there. So I have x squared over 4 times x plus 8. And you can leave it factored, especially in the denominator, right? I pretty much always leave it factored in the denominator. Let's try another one like that. So we'll factor each of these parts. That's dots, x plus 2, x minus 2. GCF is 9. I'll put the 9 out front. X plus 4. Generally, we put the coefficients out front, but 9 times x plus 4 is the factor. 1 multiplies to 8 and adds to 6. X plus 2, x plus 4. And then the last factor is x minus 8. So does anything go away? Hopefully. No. X plus 2, x plus 4. 9, x minus 2 stays in the top. And in the bottom, you have x minus 8. So we're done with that one. Last type of problem we're going to do is division. And division is we think of division as multiplying by the reciprocal. Multiply by the reciprocal. You guys probably remember this as copy, change, flip. Okay, a little less mathy. Copy the numerator, change this operation to multiplication, and then flip what would be the denominator. So this doesn't change. I'm just going to screenshot it because I can. Copy the first part, change this to multiplication, and now put x minus 9 in the top and 6x in the bottom. And I'm going to put parentheses around that, just a reminder. Now it's like the other ones. Now it's multiplication. So in the top, you have dots, x plus 2, x minus 2, x minus 9 is not going to change. What multiplies to 18 and adds to negative 11? X minus 9, x minus 2. And then I have a 6x, which, again, it's usually better to put it out front. It doesn't really matter, but to be consistent. Anything go away? Yeah. X plus 2 over 6x. One more. Copy. Change the operation to multiplication. And now we're going to flip it. So now it's 3x in the top. And while I'm at it, I'm going to factor that. What multiplies to negative 42 and adds to negative 1? Negative 7 and positive 6. Well, I guess I still have to do this part anyway. So that's dots, x plus 7, x minus 7. 3x I'll just keep in the top. GCF here is x cubed, x plus 7, and then I have this x minus 7, x plus 6 that I already factored. So what goes away? X plus 7, x minus 7. One of these x's can cancel out, but you still have 2 in the bottom. So in the top you have 3, you have x squared, and you have x plus 6. Again, I'm allowed to cancel these out because this is multiplication. If the whole thing goes away, I'm just undoing multiplication with division, so they cancel out. All right, so those are the concepts. There's a few practice problems here. I'll work through these pretty quick. First thing, copy, change, flip. So copy. I'll just factor while I do it. X plus 7, x minus 7 in the top. Dots. And then this would be GCF, x cubed, x plus 7. Is this the same one? Did I get the same question twice? Oh, well, I accidentally screenshot it, so I'm not going to do it again. It's the same one. Okay. Let's try this one. Is this the same one? No, I don't think so. 9x cubed? No, it's close though. Okay, 9x cubed, I can't do anything. In the denominator, the GCF is 18x squared, and that would be x minus 2. So I can cancel out those x's, and now there's one of them in the top. And 9 over 18 is a fraction, that's 1/2. So this is 1x over 2 times x minus 2. If you have 9 over 18, nothing has changed. That is still 1/2, 1/2. 9 over 18 can still be reduced. It's a product. The division will help you reduce it. Last couple now. Let's see. Copy, change, flip. 7x cubed doesn't change. The numbers that multiply to negative 30 and add to 1 are positive 6 and negative 5. Now I'm multiplying and I'm flipping it. So now this is x plus 6. I'm factoring that. That's dots. Now it's in the top. And in the denominator, this guy, when I factor it, is x minus 6. So what cancels out? One of these x's, so now that's 2. 7x squared in the top, x minus 5 in the bottom. One more, this is multiplication, so you don't have to flip anything. X minus 9, this is dots, x plus 8, x minus 8. What multiplies to 72 and adds to negative 17? Negative 8 and negative 9. And then the GCF here is 6. I like to write that up front. And now it's x plus 8. So what cancels out? Boom, 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 boom. Wow, 1/6. Everything canceled out except for the fraction, the 1 over 6. Okay. All right, so you guys have some practice problems to do. You got a delta method that goes along with this. Make sure you smash that like and subscribe.